Today we're going to be talking about assessing torsional eye movement. So torsional eye movement is something that is challenging to assess. Oftentimes you can see it on a video, but you also want to be able to quantify that torsional eye movement and measure that torsional eye movement. So what we're going to be talking about is identifying torsional nystagmus. The torsional module must be purchased in order to collect the data needed to provide analysis for torsional eye movement. Torsional eye movement is analyzed at 60 frames per second using a region of interest of 320 by 240 pixels. In order to reanalyze torsional data, the eye video must be saved. And this is available for all slow phase velocity tests, such as, most importantly, positional tests, but you can also use it for gaze. You could use it in caloric if you wanted to. But obviously, where we're going to focus is on our positional tests. So in the test setup, if you want to analyze torsional, you need to make sure you check the torsional box, as you see circled here in red. Now, if you do not have the torsional capabilities, that means you haven't purchased it and you don't have a license for it in your goggle. So it's a purchasable option. Once you check that and you get your pupil detection all set up, you need to make sure you collect the reference frame. And so here, when you click capture, it's going to capture the reference frame for you. So again, first adjust your pupil tracking, ask the person to keep their eyes wide open. This is going to reduce any shadows, and then you're going to collect the reference frame. Now what this does is this becomes your reference for your torsional measurement. So it's looking at this and then looks at where the eye has moved to get your slow phase velocity. So here, regarding the reference frame, here's a good quality reference frame and here's a poor quality reference frame. You can see all these shadows, eyelashes down in here, pupil is cut off by the eyelid, so you do not want a poor reference frame. Again, if you do have a poor reference frame, the quality of your data is not going to be good. Once you collect your data, you won't see the torsional trace during collection, but afterwards, all you have to do is click on TR, and it shows you your trace here. And so here's your torsional trace, and then here's your slow phase velocity graph for torsion. And we're going to show you this data. You can reanalyze the data just like you could reanalyze any of the data. You can analyze it from cursor or from the full trace, and you could also delete points in the slow phase velocity graph or choose a different peak as well. Just make sure you choose the torsional trace when you want to make modifications to it. And also under the torsional tab is where we store the reference frame. So let's look at some patient data. We're going to play back this data. So here you see the trace and the SPV graph, and then here you see the eye. So let's play back the data from the beginning. So patient's looking straight ahead, head's turned, and turned 45 degrees, and now the person is dropping them back into the Dix-Hallpike maneuver. And there you see the torsional eye movement. You see it in the video, and you see it on the trace. And it's just a little bit of torsional eye movement. It's about 14 degrees per second. So let's stop it and play it one more time, because I know it's quick. In a Dix-Hallpike, you get that burst of activity, and then the activity subsides. So this is a very traditional posterior canal BPPV. 45 degrees, bring the person back down, and now, wait, here the nystagmus starts. Beat, 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 beat. You see it on the trace, and you see it in the graph and on the eye. And then it subsides. And that's torsional analysis. Very simple.